writing an exponential growth model. It's a word problem, but that's okay. We're going to learn to love these. In 1990, the population of California was really big. It was over 29 million. There was an annual increase in population by 1.28% each year. We need to write an exponential growth model representing this situation. So I have the formula up there for writing the exponential growth model. You know, y equals a times 1 plus, it's going to be 1 plus the r value if it's a growth, raised to the t power, and we just have to fill in, you know, figure out what the variables are. So our a value is the initial amount, or in this case the initial population, so that's the 29,816,591, and the r is our rate as a decimal, so it is 1.28%. Now what I'm going to do to get this into a decimal is just move it over once, twice. So we have 0.0128. And then the t, because we're writing a model, we're actually going to have this as an equation where the t will stay as it is. So we're ready to write our, well, we'll see if it's our final answer. Y equals that huge number, 29,816,591. Of course, I didn't leave myself room, times 1 plus, let me see if I can move those over. Oh, part of it. Oh, there's more of it. Whoa. Okay. 1 plus the 0.0128 raised to the t power. So in the end here, you know, in class I talk about let's clean it up a little bit, so that just means let's go ahead and do that addition right there. So our final answer for just writing the model, which is just writing the equation for this situation, y equals 29,816,591 times 1.0128 raised to the t power. So we're actually just giving ourselves an equation that we can use to answer any question about California, such as the next question. What was the population of California in 2002? So now we're getting into, all right, we're talking about a year. How many years is 2002 since 1990? So our t value, that is 12 years later. So our t value is going to be a 12. All we do now is just plug in 12 for t to get a number. So y equals 29,816,591 times 1.0128 raised to the 12th power. At this point, it definitely is a calculator problem. We'll see how this works. I have this calculator, so there it is. And I'm going to punch this in. So we have 29,816, oh, okay, 591. I am, just to save time, I am going to do this all at once. So here's where parentheses are really important. Actually, that's not how I would have you guys do it. I would have you do the exponent first and see when I write it and it goes away. So this might be tricky. 1.0128 raised to the, there's my exponent button, to the 12th power equals. And we want this long decimal. So it's the 1.164888377. The more numbers we use from this, the more accurate our answer will be. So if I come over here, I'm going to say, okay, 29,816,591 times that number, which was 1.164888377. And when I multiply those two together, that's going to give us the final answer. So with my calculator, I actually already have that number in. So if I do times, it's going to take that answer, multiply it by our population, which is 29,816,591. And our final answer is this 34,733,000. So 34,733,000. And the 0.3, but we're talking people, so we'll leave it at this. So that is the estimated population in 2002.